Basic electrical engineering. In our previous chapter, we have learned about the conducting material. Now, we move to the next chapter, that is fifth chapter. It is about the insulating materials and its properties. Properties of physical properties, electrical properties, thermal properties, chemical properties, and mechanical properties. Here, electricity is one of the most common needs in today's modern world. However, it is more dangerous also if it is misused or its application of uses are any underestimated. Then so many problems are occurs. That is the reason when any material that carries electrical current is designed to provide some safety type of insulation. Without insulation, it is very highly dangerous to meet that conducting material without any insulation. Depend upon the voltage, sometimes it gives shock or sometimes it causes accident and it causes death, and the death too with fully burned that body also. So depend upon the material's voltage it will occurs. That's why we have to provide that limitation of insulation material. Then what will happen? The insulation limits the flow of current between the different conductor and between the conductor to ground. These insulation materials are non-metallic material that do not allow electric current to passes through it at a normal temperature. Depend upon the temperature, that insulation material also changes. We have to take care of that also. There are number of insulating materials used in this electrical engineering laboratories and machineries. Sometimes it may be organic and inorganic, sometimes it is natural, it is synthetic, like that. So many versions are there. There are many properties such as resistivity, breakdown, voltage, thermal stability, mechanical strength. We studied all the properties. Why we have to study all these properties? To determine that the suitability of a material to be used at that insulating material. An electrical insulator is a material whose internal electric charges do not flow freely and therefore make it very hard to conduct an electric current under the influence of an electric field. That's why a perfect insulator doesn't exist, but some materials such as glass, paper and Teflon, which have high resistivity, are very good electrical insulators. A much larger class of materials, even though they have lower bulk resistivity, are still good enough to insulate electrical wirings and cables. Orally, this insulating materials is usually made from a non-metallic. Metallic items are almost related to the conducting materials. This is a type of insulating materials. Here we have to study the insulating materials. It is almost of non-metallic type of materials. The majority of electrical insulation is made of PVC. PVC means polyvinyl chloride. Here we are observed PVC in our home itself. We are having some cables. That cables is of yellow, green, red, like that colors. On the top of that cable is shows some color, no, that color, that it is appeared as some plastic item. It is a PVC material. Inside the copper conductor is there, that outside layer is made with this PVC. Sometimes plastic or rubber glass is also used as insulator material. Like that, every time we require insulating material very much, otherwise it is very dangerous without an insulating material to handle and conducting material. When it passes an electrical current through that conducting material, if it is near to the ground, then it occurs very much highly accidents. That's why the material which insulates prevents the flow of current through it with a potential difference is applied across it. So insulating materials are very much used. Without proper insulation, we can't use this conducting materials. These insulating materials offers very high resistivity, 10 to the power of 12 to 10 to the power of 18 ohm meters, to obstruct the flow of this electric current without any power losses. The function of insulating material is what? To prevent any leakages of current between conductor or conductor to earth or conductor to grounding, like that. There are available in, there means these insulating materials are available in different types. Solid type insulating materials are there, and liquid types is there, and gases types is there. Almost all insulating materials have negative type of temperature coefficient of resistance. Their resistances decreases with increase in temperature. So hundreds of types are insulating materials are available in the market. So the selection of the right insulating material for a particular purpose is very much important, because the life of electrical equipment completely depends on the type of insulating material used around that material, around that machine, like that. But we are having so many types of insulator material, no? The technique to select the right material out of an ocean of material is to know the properties of material. That's why here we have to study the properties of these insulating materials. If we study the properties, then only we have to able to select the correct element. Because of that, it is a ocean. So many type of insulating materials are available in nature, in market. We have to select the right material from that much material. So many types. Insulating materials are used for many purposes in day-to-day life. In electrical winding, conductors covers with some plastic materials, rubber, or some kind of varnished cotton, porcelain insulating materials, and in overheaded and distribution lines, mica, asbestos is used in electrical iron to prevent leakage currents and electrical shock to the human beings. So many types of insulating materials are there. Right, these are the variety of insulating material, so we have to study its properties. First of all, we have to um, know about this insulating material. So many variety of materials is there now. We are having conducting material, semiconducting material, insulating material, dielectric material, and magnetic material. In this type of material, what is the future of insulating material, we have to study. Then only we deeply involved in that insulating material, and uh, if we observe the properties of these properties of physical, electrical, thermal properties, like that, then we will find the right material for the right application. Before that, we have to know what is the meaning of this insulating material. So first of all, in our electrical engineering subject, throughout in our subject, in our concepts, we are dealing so many type of materials in our day-to-day life. In our whole life, we are covered so many types of materials. The materials which are used in the field of electrical engineers are known as electrical engineering materials. Different materials possess different properties to meet the various requirements for engineering purpose. What is the ultimate aim for this? It is The aim is to select the right material in the manufacture of the electrical machine or equipment and device. There is no equation or there is no computer program or like that to select this right material. We have to study its past history of that material, then only it tells a particular application for that. Because of development in science and technology of the material, the best material sometimes back may not be the best today, and the best material today may not be the best tomorrow. It is improved a lot nowadays. So the selection of particular material for a particular application depends upon the various properties. So hence the electrical engineer should know the properties and merits and demerits of the material to choose the correct material for a particular given application. Then only it can be effectively and economically used for a specific purpose. So the properties of different materials mainly depend upon what? On their atomic structure. So our electrical engineer is a vast field which number of materials are used for different applications. The materials used in the field of electrical engineer are classified based on the properties and the applications. They are classified as conducting material, semiconducting material, insulating material, dielectric material, magnetic material, and special purpose material. Conducting material. The material which allows the electric current flows through that. These are called conducting material. This, let's see its atomic structure. It is having less than 1/2, means 1/2 means 8 is the maximum valency electrons available in atomic structure. Less than 4, if the valency electrons are less than 4, then in the outer orbit the electrons are free to move. Those free to move of these free electrons movement is known as electric current. Due to potential difference, it will move from one place to another place. So our conducting material must be having this feature. What is that? It is the valency electrons is less than 4. Example for this conducting materials are gold, silver, copper, aluminium, like that. So many applications for this are house wiring, winding of electrical machines, transmissions and distributions. And then next is insulating materials. Here insulating materials means the materials which does not allow the electric current to flow through them are called insulating materials. So these materials are very high resistivity property. Let's observe its atomic structure. It is having more than 1/2, means more than 4 valency electrons in the structure of this at the outermost orbit. So overall, the insulating material is used to prevent current flow in any path. Example for this is PVC, cotton, glass, rubber, air, mica, paper, etc. What are the applications? To isolate the live conductors in all applications from earth or body, to isolate the windings from the body in all electric machines. Here in this complete unit we are going to study about this insulating material and special purpose material. We are already studied about this conducting material. The next thing is semiconducting material. Here let's see the example germanium. This is the atomic structure for this. See its outermost orbit. The outermost orbit is contains 4 valency 1 2 3 4, exactly 4 valency electrons. So semiconducting materials having exactly 4 valence electrons. That's why it is a features or these properties are lies between the insulators and conductors, which has electrical properties between those of insulators and conductors. So semiconductors is neither a conductor nor a insulator. The resistivity is the order of 10 to the power of 0 to 10 square ohm meter. So these are manufactured in electronic circuits, rectifiers and control circuits, photoconductive and solar cells, photovoltaic cells, like that. It is also used in our electrical applications. Next, dielectric materials. Dielectric materials are also insulating materials. That is a poor conductor of electricity, but an efficient supporter of electrostatic field. It means that this type of dielectric materials are insulating materials which possess a very low electrical conductivity. Dielectric materials are essentially insulating materials. However, the function of insulating material is to prevent or to obstruct the flow of current, while the function of this dielectric material is to store the electrical energy. So that is the difference between this dielectric material and insulating material. Insulating material completely prevents the flow of electrons, but here the dielectric material is used to store electrical energy. So this is also important feature in our electrical engineering applicants. What is the application for this? Capacitor. The capacitor stores the amount of energy. When the source is not available in that particular circuit, then this capacitor discharges the energy. It supplies the energy to the remaining equipment to the circuit. What is example for this dielectric material? Porcelain, mica, glass, plastic, dry air, vacuum, like that. The next thing is about the magnetic material. The magnetic material which provides a path for the magnetic flux. Magnetic materials are material. It can be either attract or repelled when placed in external magnetic field and can be magnetized themselves. So this magnetic material also plays a very much important role in our electrical engineering field. These are used to provide magnetic flux. By using this magnetic material only, we are manufactured so many machines, motors, generators with like that. Without this electromechanical energy conversion, there is no rotating electrical machine or transformer is there. This is also very much important in our electromechanical conversions. Without this magnetic material, there is no scope for any type of machines, motor, generator or transformer. So what is the example for this? Iron, cobalt, steel. nickel, like that. Right? Special purpose materials. In our electrical engineering life, throughout the field, we are observed the conducting material, insulating material, semiconducting material, dielectric material, magnetic material. In addition to these special purpose material also there. In this particular unit, we are studied about the insulating material and special purpose material. So what is this special purpose material? The material which are used for special purposes in the particular field of electrical engineering. There are number of materials which are used to perform special functions. These type of materials are special purpose materials. So these materials are used for such applications, special applications such as fuses, soldering, galvanizing, integration, like that. These are the special purpose materials. It is not coming under the conductor or insulator or semiconductor. It is completely special. It is related to that particular application only. Let's see the example for this. Tin, lead, zinc chloride, varnish, silver. These are some special purpose materials. Applications are soldering, integrations, varnishings, fuses, and circuit breakers used in switchgear and protection, like that. Right? So, depend upon the atomic structures, these materials are classified as conducting, semiconducting, and insulating materials. Here, another property is there, resistivity. So, resistivity is the resistance between the two opposite faces of a cube having each sides equal to 1 meter. Resistivity of conducting materials is 10 to the power of minus 8 to 10 to the power of minus 3 ohm meter. Means here the resistance is very less, then the current flow will be high. Here the conductors are allowed electricity. After that, insulators. The insulators resistance is 10 to the power of 10 to 10 to the power of 20 ohm meter. Means its resistance is high, 10 to the power of 10 to 10 to the power of 20. These are called high resistive materials. Now we are going to study about this type of materials only in this unit. Due to this high resistance, it prevents or obstructs the flow of electric current in the particular circuit. So it is very much required to cover a conductor with the insulating material to provide safety, to prevent leakages of the current to the ground or from one circuit to another circuit, like that. So these are the required point, that is insulating material is having the high resistance. It is a value of 10 to the power of 10 to 10 to the power of 20 ohm meter. Right? After that, semiconducting materials 100 to 0.5 ohm meters. So orally, our engineering appliances, this insulating material offers a very wide range of uses. Without an insulating material, it is very high level risk. It is very dangerous to use a conducting material. The materials which have very high resistivity, just we are observe how much it is, 10 to the power of 10 to 10 to the power of 20 ohm meters, offers a very high resistance to the flow of electric current. So insulating materials plays an very much important role in various electric and electronic circuit. In domestic wiring, insulating materials protect us from shock and also prevent leakage currents. What are the properties of insulating materials? The properties are classified as electrical properties, thermal properties, chemical properties, physical or mechanical properties. These are the different properties we have to study about this. If you study all these properties, then only we are able to understand about that particular material. Then we pick the right material for a correct application. Otherwise, we are not able to select which material is useful for a particular application. So you have to study these properties. These are classified broadly as electrical properties, mechanical properties, thermal properties, chemical properties. Sometimes visual properties also important, and economically also we are considered. Right? Let's see its electrical properties. These electrical properties, in these electrical properties, we are going to study about the insulation resistance, volume resistance, surface resistance, dielectric strength, dielectric loss, power factor. These are the some various electric properties of this insulating material. In this, the top one is the insulation resistance. The insulation resistances are generally the value of 10 to the power of 10 to 10 to the power of 20. We have to study its insulation resistance and its conditions. These values are changed based on the temperature. So we have to take care of this. So first of all, see what is the insulation resistance. The resistance offered to the flow of electric current through the material is called insulation resistance. This is very much important property. The resistance offered to the flow of electric current through the material is called insulation resistance. So to study about this insulating material, we have to study its volume insulation resistance and surface insulation resistance also. The primary function of insulating material is to insulate electricity. Hence, these electrical properties are very much important. What are the electrical properties? Insulation resistance. Insulation resistance covers the volume resistance and surface resistance also. After the insulation resistance, dielectric strength, dielectric loss, and power factor. So this is the insulation resistance. First of all, what is this insulation resistance? It is a property of insulating material by which a material which opposes the flow of electric current. An insulating material should have high insulation resistance. If a voltage V is applied to an insulator in which a current of I is flowing, the insulation resistant R is given by what? According to Ohm's law, R is equal to V by I. Right? So this is the insulation resistance. Depend upon this resistance only, the electric flow will be stopped or abstract. So in depth we have to study about this insulation resistance. This insulation resistance of two types. One is a volume resistance and second one is a surface resistance. Volume resistance. So volume resistance means it is a resistance offered to the current which flows through the volume of the material. For a cube of unit dimensions, this is called volume resistivity and it is measured in ohm meters. According to physics, what is the formula for this? Let's see. R is equal to rho L by A. Right? Here R suffix V is the volume resistance of the material. Rho suffix V is the volume resistivity. L is length of the material. A is area of cross section. R is equal to rho L by A. Here RV is the volume resistance. Means it is the resistance offered to the current which flows through the volume of the material. Next, surface resistance. The resistance offers to the current which flows over the surface of the insulating material is called surface insulating material. The surface resistivity is numerically equal to the resistance of a unit square over the surface of the insulating material. And it is expressed in ohm per square meter or ohm per square centimeter. Here see, this is a cube. The insulating material is from A to B and then B to C. See, it is in blue ink. I write that A to B, B to C. It is surface insulating material. Volume resistance is from A to C. Here this is from A to C. It is observed, right? Here surface resistance is from A to B, A to B, B to C, like that. This is the difference between this volume resistance and surface insulating resistance. So what are the factors affecting these insulating materials? The factors affecting these insulating resistances is temperature, moisture, applied voltage, aging, like that. If the operating voltage is increased gradually at some value of voltage, the breakdown of the insulating material will occur. It is very dangerous phenomena. That's why we have to select the proper insulating material for the particular application by considering the voltage. If the voltage rating is high, then if we select a normal insulating material for a high level voltage, then The insulation is not bared, that insulation resistance is not sufficient to bear that much of heavy voltage. That's why if we select the particular insulating material for a particular voltage, if we select the proper thing, but if the voltage is increased or heavy voltages are came in that circuit, then what happened? It has some limit. More than that, if we increases the temperature, then automatically the breakdown of the insulating material will occurs. So we have to consider its voltage rating. Otherwise, by suddenly or by accidentally, if the voltage of that material is increased, then that insulating material resistance is not sufficient to bear that much of voltage. That's why this breakdown is occurs. And the next one is the property which attributes to such type of breakdown is called the dielectric strength. This is the next feature. To study the electrical properties, the first one is insulation material. Up to now we are learning about the insulating resistance, and in between these two types, that is surface and volume insulation resistance. This is the first point comes under electrical property. After the insulating resistance, the second point is about this dielectric strength. Dielectric strength or breakdown voltage. The minimum voltage at which insulating material will resulting in the destruction of its insulating property is known as dielectric strength or breakdown voltage. It is expressed in kilovolts per centimeter. An insulating material should have sufficient dielectric strength, as it determines the capacity of that insulating material. This is very much important definition. For your 1 mark question also, it comes in your exams. Define dielectric strength, or what is a breakdown voltage, like that. Just read this definition one more time. The minimum voltage at which insulating material will result in the destruction or breaks of its insulating material properties. It is known as dielectric strength or breakdown voltage. It is expressed as kilovolts per centimeter. Next, dielectric losses. Electrical energy absorbed by the insulating material and dissipated in the form of heat. When it is happened, when an voltage is applied, then this electrical energy absorbed by the insulating material is dissipated in the form of heat. Across it is called dielectric loss. When a perfect insulation is subjected to alternating voltage, it is like alternating voltage. When an AC is applied, alternating current is applied to the commercial insulating material. The leakage current does not lead applied voltage by exactly 90 degrees, and hence there will be definite amount of dissipation of energy in the form of heat. So this type of heat is known as dielectric loss. It must be low. It must be low. One more time I will tell. What is this dielectric loss? When some voltage is applied, then this insulating material absorbs this electrical energy. This is not a conducting material, no, to conduct this electricity. Even though we are applied voltage, this insulating material takes that, but it converts that electrical energy into heat energy and dissipated in the form of heat. This is called power loss and it is known as dielectric loss. It must be less. The insulating material should have high insulation resistance in order to limit the leakage current to a safe value. The following are the factors that affects the insulating resistance of a material. What are these? These are temperature, moisture, voltage, aging. Right? Temperature. Insulation resistance is very much affected by this temperature. With rise in temperature, the dielectric loss also increases, and at the same time, the insulation resistance also decreases. Due to this temperature, the losses will be high. After that, moisture. See, this is a graph of the resistance versus temperature. As the temperature of the insulation resistance falling, moisture decreases the surface resistance and causes insulation breakdown. When the material is exposed to atmosphere, then insulation resistance is reduced. That's why the material should be non-hygroscopic. After that, applied voltage. Insulation resistance decreases with the increase in applied voltage, and the losses also high. Here dielectric losses are rises with rise in applied voltage. This loss is one factor in limiting this operating voltage of undergrounded cables also. This applied voltage also affects the insulation resistance. The insulation resistance are decreased with increase in its voltage. After that, the last factor is age. Insulation resistance decrease with age. This is known as aging effect. That's why for every machine or every cable, the manufacturer give its um, life period, the life of, for example, the life of underground paper insulated cable is of 40 to 50 years, like that. Because of that, after a particular time period, the aging effect will occur. The resistance automatically decreases with this increase in age. It is generally happen. So these are the factors. What are those? Temperature, moisture, voltage and age. These are the electrical properties we are studied about our insulating materials. What are the electrical properties? Insulation resistance. In that insulation resistance, two types is there: volume and surface resistance. After that, dielectric strength or breakdown voltage. Next, dielectric loss and power factor. The power factor, last one, power factor of the insulating material is a measure of power loss. It increases with increase in temperature, and rapid increase indicates danger. Right? These are the factors we are studied its properties. What are the factors? Temperature, moisture, voltage and age. This is about the insulating materials electrical properties. In continuation to that, we have to study its thermal properties, physical chemical properties are also. But electrical properties are utmost important. That's why we are studied in depth. Hope you understand this. Study the concept one more time in your textbook. Thank you, and thank you for watching this.